Okay, so here's some extra examples for section 12.6, spheres and surface area and volumes. So this first one is actually a surface area of a sphere, and they've got this, the great circle circumference is 2 pi. Well, circumference is 2 pi r, so 2 pi equals 2 pi r. That means the radius is 1 when you divide it with the 2 pi. So surface area is 4 pi r squared. 4 pi times 1 squared, so it's simply 4 pi centimeters squared. Okay. Next example, number 22. We're going to find the volume of a sphere, but this time we've got the area of a great circle. Well, if it's area of the great circle, area is pi r squared. So 49 pi equals pi r squared. Divide by pi. 49 is r squared. Take the square root. 7 is the radius. So volume of a sphere is 4/3 pi r cubed. So 4/3 pi times 7 cubed. That's to be 343 times 4. 2, 1, 7, 1, 13. So 1372 over 3 pi meters cubed. There we go. Okay. All right, pufferfish. Next example, pufferfish. We did this one in class too. A pufferfish is able to puff up when threatened by gulping water and inflating its body. The pufferfish at the right is approximately a sphere with a diameter of 5 inches. Its surface area when inflated is about 1.5 times its normal surface area. What is the surface area of the fish when it is not puffed up? Okay, so here's the deal. We got to figure out what's the surface area of this puffed up pufferfish. So right now it's puffed up with a diameter of 5 inches. Well, surface area is 4 pi r squared. So if the diameter is 5, the radius is 2.5. So surface area is 4 pi times 2.5 squared. So 6.25 times 4 is going to be 25. So 25 pi inches squared is the surface area of the pufferfish right now, but it's the large pufferfish. So I need to know, so I know that this is 1.5 times the smaller one. So I need to divide by 1.5. Okay. So 25 pi divided by 1.5. Which is 52.4. That's the smaller one. Okay. Right. Now the last problem. Okay. Last problem we're going to look at is a bit of a tricky one. You're supposed to find the surface area and the volume. We'll do the volume first because volume's actually easiest. So volume for this guy, we have a prism, but you're cutting out a hemisphere. Okay. So the prism is area of the base times the height. So it's 10 by 10 by 13 minus 1/2 4/3 pi, but the radius, if this is 10, is 5 cubed. So that's pretty straightforward, I think, to see that you got a big prism here and you're going to cut out a hemisphere. So it's 10 by 10 for the base, height is 13, and then 1/2 4/3 pi r cubed for the hemisphere. Well, it's 4/3 times 1/2 times 5 cubed. So 10 times 10 times 13 minus 1/2 times 4/3 times pi times 5 cubed. And that's 1038.2. cubic centimeters. Now, here's the tricky part. The tricky part is the surface area. Because the surface area is the surface area for a prism. Okay. It's a prism, so it's 2b plus pH. But then notice I cut out this circle here and filled in with this hemisphere. So I need to take out a circle and then add in 1/2 of 2 pi r squared. Okay. So we got a lot of stuff to fill in here. Now, the base is 10 by 10. So it's 2 times 100 plus perimeter. Well, that's 40 because it's 10 plus 10 plus 10 plus 10. So 40 times 13 minus pi times 5 squared plus 1/2 2 times, oh sorry, it should be 4. 1/2 4 pi r, which is 5 squared. So there's a whole mess of stuff to do there. So now we throw it all into the calculator. Excuse me, so 2 times 100 plus 40 times 13 minus pi times 5 squared, which is 25, plus 0.5 times 4 times pi times 25. And then it gives us 798.5. Squared centimeters. Okay.